Hey, course one, we're going to focus on a theorem today, something that was found a long time ago and proven true. It's a fact, a law of math that becomes very useful for finding a missing side length in triangles, as long as we're talking triangles. It's called the Pythagorean Theorem. Whisper that to yourself. Pythagorean Theorem. Founded by a guy named Pythagoras, a mathematician back in, I believe, the Greek days. So, longest side I introduced to you last time. The longest side of a triangle is right here, opposite the biggest angle, and it's going to be called a hypotenuse. The other two sides are just called, legs, I guess. That's what we usually call them. Notice the legs are the sides that form the right angle, which is right here. And the hypotenuse is opposite a right angle. So what we're using today is a theorem that works for right triangles when we're missing the hypotenuse. The area of a square drawn on the hypotenuse of a right triangle equals the sum of the areas of squares drawn on the legs. I'll show you why this is helpful. The Pythagorean theorem is an equation that relates the sides of a right triangle in this way. The sum of the squares of the legs equals the square of the hypotenuse. This is pretty hard to see too. But we square a leg length, we square the other leg length, we add that together, and it gives us the hypotenuse squared. So we show this in short, leg 1, leg 2 is the hypotenuse squared, or a squared plus b squared equals c squared. One of the most important things you'll learn in math this year. Remember it. Memorize it. If you need it, put it on your cheat sheet. If this is easy enough to memorize, then there you go. As many as 4,000 years ago, ancient Egyptians knew about this. Today, the relationship for is named for a Greek mathematician who lived about 550 BC, Pythagoras. So that's why it's called the Pythagorean Theorem. It's his theorem. But the Egyptians probably knew it too. They did amazing things with math. So I want you to go ahead and do example 1 along with me, maybe on graph paper, just so you can count your lengths, or you could just measure them with a ruler, or I guess you can just write them out like this book does. But it'd be good to have this as a proof. We're going to prove that a squared plus b squared is c squared. Okay, so what we're really doing is when we do a squared, we're finding, let's say this leg, we're finding what's the area of a square with side lengths of that leg, right? A squared, 8 squared, 64, plus b squared, right, is another one that forms the right angle. So we're building a triangle. Measure that to make sure it's 6 on all sides. So if it's 6 on all sides, it's 36 for an area. What's that come to if we didn't know c? C squared. 64 plus 36 is 100. They're making this easy for us. Is c squared, understand? So what is c? It's saying, well, c times c is 100. What would work for c then? What would c squared? So c would be 10, because if I put in 10 for c here, it would equal 100. 64 plus 36 equals 100. 6 squared plus 8 squared is 10 squared. C is worth 10 centimeters. We learned that without actually knowing the length of C. And I hope you were able to draw those out and write the areas in the middle. It's true that the area of this plus the area of this equals this area, which can then give us a missing side length. That's what we're doing today. So if you draw a square on each side of this, you got 144 for an area here, but we're missing the A. We know the hypotenuse, but we can still use it. We say we're missing A is 13 squared, which they say is 169. So move the 144 over. So it just says A equals 169 minus 144 is 25, if you follow what I'm doing. That's A squared. So A would be 5. This is worth 5. Pythagorean theorem. A Pythagorean triple are 3 numbers for lengths of sides on a triangle that are commonly found together. If you've got a 3 and a 4, then you know, without having to do all that pesky equation work, that the hypotenuse is 5. It's just something you can memorize. If you know 5 and 12 are the legs, then 13 is the hypotenuse. How do I know that that's the hypotenuse? Because it's always the longest side length. So 8 and 15 are your legs. 17 is automatically your hypotenuse. Here is the illustration of 6, 8, 10, which we already did. Are 2, 3, 4 a Pythagorean triple, it asks? No, it's not, because 2 squared, or 4, plus b squared, which is 9, is not quite 16, which is c squared, or 4 squared. Pythagorean triples. You can apply it to all right triangles, and only right triangles, not other kinds. It's also true that if the sides of a triangle are related by the Pythagorean theorem, then the triangle is a right triangle. So if you ever find the sides were a squared plus b squared equals c squared, but you didn't know the last angle, you wouldn't know that it has an ID. You would, because it had that Pythagorean relationship. So we can actually identify a triangle as right when we can prove that its lengths relate, like according to the Pythagorean theorem. Okay. The Pythagorean puzzle. Have fun with this. It's really important geometry. It's probably one of the biggest goals for you to master before you move on from course 3. I know you can do it. Ask questions. Work with your friends. I'll let you know what you have to get done for now.